When I first started to talk about fractions, I believe in section 1.5, um, one of the things I illustrated was about the slice of pies and how we need them to be sliced the same way in order to add them together. Well, now that's what we're going to work on. We're going to talk about adding and subtracting fractions. We're going to do this with some algebraic kind of twist here. But so I want to add these up. These are sliced the same. Both of these pies have been cut into thirds. So do you remember how we would do that if we did 1/3 plus 1/3? You can just keep the slice of pie and you add the top, so you'd get 2/3. Well, here we've got a little algebra involved. X plus 2, they can't be combined any further, but we get x plus 2 over the 3. So we're following the same pattern, even though it's algebra now. We've got I don't know plus 2 on the top over the 3. So here I have the common denominator, so that's the slice they're sliced into fourths. So we just add the top, but because it's algebra there and they're not the same kind of thing, we can't go any farther. So this would of course then be this. All right, we can go the other way. So we don't have any algebra on this one, but so we can go the other way too. I am already sliced the same way. I have a common denominator there, so I'm just going to put it over 24. And so the problem then becomes negative 23 minus 13. Okay, well, you owe me 23, you owe me 13 more. You now owe me 36. All right, so we get down to here. Now we could reduce this just like we always could. These are both divisible by 12, or you could break down all the factors and reduce it down to 3 over 2. And then they're showing us here that a negative up top is the same as out front. And so when we finish with a fraction, we usually will just put the negative sign in the front. Okay, so my bottom, the denominator there, is a match. So this is going to be over 28. So I'm going to do negative 19 minus 7. You owe me 19, you owe me 7 more. Okay, now we could cut this down. Yeah, actually 2 is I think all you can do. I was going to break this all the way down, but it's, well, I'll show you in case you need a little refresher here. Okay, so I have this broken down. 13 doesn't go any farther. It's prime. So I cancel that common factor. Now I'm going to put the negative out front, and I've got 13. Put the 2 and 7 back together. All right, these are a match, so they already have the common denominator. So I'm doing this. Okay, so I already kind of see where this is going. But if you don't, let's go ahead and this makes a whole lot of 2's. Okay, so I've got it all broken down. You don't have to do this if you see what they're both divisible by. But again, from an algebra perspective, this is the way, very useful information. Factors are so important in algebra. Okay, I'm going to put the negative out front. 2 times 2 times 2, I'm going to put it back together, and I get an 8. Now, even though this the bottom now is I don't know, it does match. So I can put that together. So the denominator is going to be x now. Even though it's going to follow all the same rules of fractions. It will never break them. Okay, I've got negative 10 minus 4 is negative 14. Just put the minus out front. So I get negative 9 minus 7, all of that over x. So the denominator was a match, so I can do this. Negative 16 over x. Okay, I don't really need to rewrite this, but I should maybe put that negative out front. Okay, same thing. It's all over a. All right, we have 3 of them now, but it doesn't change anything. I don't know how they did it. I'm just going to do, I have the 2 signs in a row, which I don't like. I'm going to just make that subtraction. Okay, all of these have a common denominator, so it's all, the final answer is going to be over 8. I'm doing 3 minus 5 minus 1. So what do I get? Negative 2, negative 3 over 8. I wouldn't need you to rewrite that. I would have been fine with it, but I just put it up front. Okay, I'm going to take care of this double sign thing here and make this negative 4 over 9. Plus and minus makes a negative. Okay, now they're all over 9, so I'm going to turn this into negative 2, negative 4, negative 7. Okay. All right, negative 13 over 9. Okay, one more of this type anyway. Plus and minus, make a minus. I've got 5 minus 4 minus 7 all over 9. That's what we're going to do. So what do I get there? I get 1, negative 6 over 9. Now this can reduce. You could do the factor method, but they both are divisible by 3. And I get this. All right, now what do you do when the denominators are not the same? I actually alluded to this in our very first lesson here. So we need to get a common denominator for these guys. So we need two numbers that they can both become. Now this is showing, we saw this quite a ways back. This was how to find, we saw this for finding the least common multiple, and it'll still apply here. Usually when they give us the fractions, they'll be easy to kind of just tell what they should both turn into. But if you can't see that, then this is the approach you would use. So I factored 12, I factored 18, and the way this worked was, for any match, you brought it down once. Any match, you brought it down once, and then anything else comes down individually. So I have 1, 2, 1, 3, another 2, and another 3 makes 36. So if you didn't see 36 was where we're going, that's what we need to do. So we need these both to be, I'm going to do it over here. I know it's already written, but so I need to turn these both into 36. Now how am I going to do that? Well, to turn 12 into 36, you multiply by 3. But this is what we were talking about earlier. You can't just change the bottom. You have to slice it the same, but if you change it, you got to do it to the top as well. So that becomes 21. Okay, I need to turn this so it's sliced the same, but if you do it to the bottom, you got to do it to the top. Now look what we've done. They're sliced the same, so I have 31 36. Okay. Yeah, that's not an easy one. So I'm going to do our factoring approach here. Okay, so what are we trying to turn this into? Well, the matching 3's will contribute a single 3. So then we bring down anything that doesn't match from either one of them. So see what I'm doing? 1, 3 comes down, everything else just slides down. So what I'm looking for here is 4, 20, 60 is the one. Oh yeah, I can see it now. So 60 is what we want to turn them both into. Okay, now we can't just change them. So I need to multiply him by 5 to get there. So I got to do it to the top. This guy times 4, but if I do it to the bottom, I got to do it to the top. Okay, we have a common denominator now, so we can just add them up. Get 79 over 60. And I would be okay with improper fractions. So like you could turn this into mixed numbers, but in algebra we would just leave it most of the time. Okay, so I think I see this one, but just in case this helps you. Okay, I broke him down. I did it this way so that I could lasso this guy. So bring down a single 5. Bring down every other number, the individual numbers. So what I've got 15, 30, 60. So I need to turn them both into 60. Okay, do this to the bottom. So I want to turn 15 into 60, that'd be by 4. Do it to the bottom, you do it to the top. 20 times 3 is what's necessary there. Okay, so they have a common denominator now, so I'm going to add them up. I get 103 over 60. Okay, nothing changes with subtraction. We're going to do the same plan. So let's let them do a little bit of the work for us. So yeah, they keep picking ones that are difficult. Usually you can kind of tell what you want the denominator to be, but these are tougher. So they played the game again. They found out it's 120. Okay, so we got to do the same to the top and the bottom. Now we have that common denominator. So 56 minus 95 gets us this. Now they checked to reduce it. They factored it down. I like it when they do that. Factored it down. The 3's will cancel. Oh boy, they do keep picking difficult numbers. Okay, so let's see. This is alright, so I broke them down. Now we're gonna, every time there's a pair, it contributes just 1. Yeah, so this is what we got. So we're contributing, the circles are giving 3 2's. Now everything else is this. So what do I got? I got 4, 32 times 3. So we're looking for 96. Okay. I'm trying to wrap my head around what the trick would be to get there. Yeah. Yeah, that makes sense. What you'd have to do, so if you had this little table set up here, how do I get from 24 to 96? It's going to be the 2 2's that the other one had. So I'm going to multiply by 4 to get there. So if I multiply the bottom times 4, it's going to be the top. Needs the same. So 12, 52. Now, what did 32 need to get there? It'd be the thing it was missing from the 24. It'll be a 3. Okay, 52 over 96. So they have a common denominator now, so the answer is going to be over 96. I can just subtract the tops. I get 1. All right, they are in love here with the difficult ones. So I'm going to break this down. Okay, so circle contributes 1. Everything else comes down individually. So I got 16, 32 times 7. I'm just going to let my calculator do that for me. Get 224. Okay, I need to turn 32 into 224. Well, the way to do it is what it was missing. It didn't have the 7. So I got to multiply the top and the bottom times 7. Okay, now I'm turning 28 into 224. Okay, it's missing 2 times 2 times 2. It's missing 8. So multiply the top and the bottom by 8. Okay, so now I have my common denominator. And then I'm just subtracting 75. Okay, 75 is made up of 3 and 5 and 5. So the only way I would be able to factor this is if this number is divisible by 3. And so I'm going to check my rule where you add up all the digits, 4, 5, 6, 7, 8. No, this is not divisible by 3. And it's not divisible by 5, so that's the best we can do. Okay, so we've got some idle no's in here, but it doesn't change anything. We're going to play the same game. So I can turn 5 and 8 into 40. Okay, so to do that, top and bottom by 8 here, top and bottom by 5. Now x times 5 is just 5x. In algebra we always like to put the number in front of the I don't know. Okay, now they have the common denominator, but when we try to add them, nothing combines. And so we have that. All right. So I'm trying to turn these into 54. Is there a lower one? No, I don't think so. Well, I don't know. Is there a lower one? Let me see. So that would come down once. So we get 1, 3 from that. Oh yeah, of course, should have seen that. Okay. So 18 would have been a faster way to do that. So 6 times 3 makes 18. Do it to the bottom, I got to do it to the top. So I get 3y. 9 times 2, got to do it to the top. Get 14. Okay, the denominator's the same. The top, then, they don't really combine. The best I can do is 3y plus 14. Okay. Alright, I'm pretty sure I can't do any better than 30 on these. So to turn them into 30, top and bottom times 5, top and bottom times 2. Okay, got the common denominator. We're just going to add up the top. And I get this, because you can't go any farther. Okay, hold on, I want to see what's left here. I guess they're just reviewing it all, I guess. Okay, so let's let them do the hard work for us. So if we're adding and subtracting fractions, we have to get a common denominator. So they got these both over 30, and then they put it together. If we're multiplying, we're just going to make the top and the bottom. So everything on the top and everything on the bottom goes together as factors. Now we can factor down and cancel the matches. Okay, so we're going to turn these both into 36. So he needs a 4, he needs a 4, he needs a 9, so he needs a 9. Alright, we have a common denominator, so I'm going to put those together over 36. Now this is multiplication, so we can really think of it as all being on one fraction. So I'm going to turn this into 3 times a. Okay, anything on the top can cancel with any matching factor on the bottom. So I get all this. Now the a is over here, but I want to put it 2a. Doesn't matter the order that you write it. And we usually put them in front of there. So 2a over 3. Okay, pause this if you want to try. And if this feels pretty easy to you, that's okay. Just make sure you got it. Because again, students really struggle with this. I'm going to turn these both into 30. So I'm going to multiply him by 6. But do it to the bottom, I do it to the top. M times 5. Gotta do it to the top of the bottom. Okay. Now over here, I'm going to put it all top and the bottom. Okay, so I'm going to turn this into 2 times k. The 1 doesn't really do anything. Down here, 5 times 2 times 3. Cancel the matching factors. You've got 2k over 15. Alright, so a lot of fractions. Nobody loves that stuff. But I hope that makes sense. And again, I keep saying this, but make sure you have this down. You can totally do it, and we're going to need these factor principles when we get to much harder material later on.